Hey guys, this is Axel and you are watching Quick Mac Shots. Today we will be studying about the working of Pelton wheel and its efficiency. So let us begin. This is the basic diagram of Pelton wheel. A Pelton wheel is having buckets and a nozzle is used to form a jet, or we can say in this water is admitted in form of jet through the nozzle with velocity c1. So this is the diagram of a bucket where this is the jet. So let us make the velocity diagrams first. At the inlet, the velocity diagram will be like this. Will be c1 equals to c theta 1. This part is u1 or equals to u, and this part is w theta 1. Now for this portion, the velocity diagram will be this one is W2, this one is U2, this one is C2. This whole portion is W theta 2, this one is C theta 2. This is the blade angle beta. Now the force that is acting on the blade, or that is acting on the bucket, will be m dot c theta 1 minus c theta 2. So mass flow rate is given as rho into q, whereas c theta 1 is equal to c1 minus c theta 2. From this figure we can write c theta 2 equals to u2 minus w theta 2. So putting the value over here, u2 minus w theta 2. So we are getting rho q c1 minus u2, and this u2 is also equals to u. 1 equals to u. Fine. So c1 minus u2 plus w theta 2. So from this we have rho q c1 minus u plus w theta 2. So it can be written as F equals to rho q c1 minus u will be, from this figure, w theta 1 equals to w1. So we can write it as c1 minus u plus, from this figure we can write w theta 2 as w2 cos beta. As given in this one, w theta 1 is equals to w1. So from this one, c1 minus u gives us w1. So rho q equals to w1 plus w2 cos beta, or equals to rho q, taking w1 as common, we can write w1 1 plus cos beta in this way, where k equals to w2 by w1. Rho q w1 1 plus k cos beta. I have skipped one step here. It can be written as w1 taken as common, 1 plus W2 by W1 cos beta. Now what is K? K is the blade coefficient of friction. So we have this equation. Now we need to know what is the power. Power equals to force into velocity. So it is given as rho q W1. It can also be written as, instead of W1 we can write C1 minus U into 1 plus K cos beta. So it can be written as rho q C1 minus U into 1 plus K cos beta into U. Now this is the output power. Now the power input is equals to half m C1 square, half m dot C1 square, or we can write it as rho q C1 square by 2. Now the efficiency will be given as efficiency of Pelton wheel will be equals to output power by input power, or equals to rho q C1 minus U into U 1 plus K cos beta from this portion divided by rho q C1 square by 2. Now rho q will get cancelled, so we have 2U 1 plus K cos beta by C1 square. Here again. Now for maximum efficiency, we have derivative of efficiency with respect to U will be equals to 0. So if we are doing the derivative of this value, we will get ddu of (2u) C1 minus U 1 plus K cos beta whole by C1 square equals to 0. Now when we are finding the derivative of this, we will get it as C1 minus 2U equals to 0, or C1 equals to 2U. Now putting the value for maximum efficiency. So the maximum efficiency will be putting the value in place of C1 as 2U in this part. So we will get 2U in place of C1, we are putting 2U minus U 1 plus K cos beta by 2U whole square. So we are getting 2U into U into 1 plus K cos beta whole by 4U square. Cancelling this, so we finally have maximum efficiency of Pelton wheel as 1 plus K cos beta by 2. Hence, this is the maximum efficiency for Pelton wheel, where K is the blade friction coefficient and beta is the angle, blade angle being formed. So, thank you. Please like this video and subscribe my channel for further videos.